Welcome back. Today, we're diving into something really, really cool. It's a new kind of AI that's learning to do more than just listen to our words. We're talking about an AI that can actually understand the vibe of a room by figuring out the hidden shape of a conversation. It sounds wild, I know. Okay, let's get into it.
So, first things first, let's set the stage. What's the actual problem that this technology is trying to solve? What is it about the way we humans interact that AI just doesn't quite get yet? I want you to imagine a really lively party. The research actually mentions these Gaelic ceilidhs, which are full of music and dancing. You've got people moving around, little groups forming and then breaking apart. There's just this energy, right? A social buzz. Can an AI really understand that? Can it actually grasp the vibe of the room? And this slide just nails the core difference. On one side, you've got your traditional AI. It sees people like pins on a map, locked into specific X and Y coordinates. The problem? If someone moves, the whole system kind of panics. It's brittle. But this new topological AI, it doesn't care where you are in the room. It sees the network, the connections, the relationships between people that stay strong no matter who's standing where. It's flexible.
Okay, so you're probably wondering, how on earth does it do that? How can an AI learn to think in these squishy, flexible social shapes instead of just rigid points on a grid? Well, the answer comes from this absolutely beautiful field of mathematics.
And that field is called topology. Now just think of it as the mathematics of shapes. It's all about studying the properties of an object that don't change when you stretch it or bend it or twist it all around. The only rules are you can't tear it and you can't glue new bits on.
And here's the classic example you always hear. From a topology point of view, a donut and a coffee cup are exactly the same shape. And you're thinking, no way! But think about it. What do they both have in common? They both have exactly one hole. You could, in theory, just squish and stretch a clay donut into the shape of a coffee cup without ever tearing it. It's that single essential hole that defines them both.
So this leads to this really powerful idea, this leap. What if a great conversation, a really engaging one, also has a fundamental shape? What if that back and forth between a close group of people actually creates a stable, persistent loop, a shape that an AI can spot?
So here's the game plan. Step 1. The AI just figures out who's in the room. Simple enough. Step 2. It starts mapping out their connections. Who's talking to whom, and how strong is that interaction? Then, for step 3, and this is the magic, it uses a powerful tool called Persistent Homology to hunt for those stable interaction loops. These loops are basically the core conversational groups, the ones that really define the social vibe of the whole event.
Okay, this is where things get really, really clever. So we've got this fuzzy idea of social connection over here, and then we have the hard rules of geometric shapes over here. We need some way to build a bridge between them.
And that's the big question, right? How do you take something messy and human, like social correlation, and translate it into the clean, hard numerical data that geometry and topology need to work? You've got to build a mathematical bridge.
And here it is. This is the secret sauce. The source material calls it the mathematical bridge. This one elegant little formula is the key that unlocks this entire process. It's what lets the AI turn social dynamics into a language that topology can actually understand and analyze.
Let's break that down real quick. C is the social correlation, basically how tight the connection is between two people. The formula takes that value and turns it into D, which is a geometric distance. Now, why is this formula so important? Well, it satisfies something called the Triangle Inequality. All that really means is that it makes sure the distances make common sense. The shortest path between A and B is a straight line. This is absolutely crucial because it stops the AI from building crazy, nonsensical shapes and makes sure its analysis is based on real, valid geometry.
Okay, so the theory is brilliant, right? But does it actually work? How do you measure success? How do we know for sure that the AI is really finding these social shapes and not just, getting lucky?
The goal had to be super specific. The researchers needed a number, a hard score, that proved the AI could consistently find and track these social loops, not just in one situation, but across many different sessions. It's all about proving that it's reliable. And they gave this final score a fantastic name. I love this. They call it the gold nugget. This is the one number that shows they've struck gold, that the whole system actually works.
And there it is, 87.75 out of 100. That's the AI's social cognitive score, based on data from 4 different sessions. Now that's a really powerful number. It shows a consistent, high-level ability to find those social groups every single time, proving the concept is solid.
So we have the big idea, we have the math, we have the score that proves it works, but what do you do with all of that? How do you package this intelligence so it's actually useful to other people out in the real world?
The whole analysis, from start to finish, gets compiled into what's called a professional portfolio. And this isn't just some internal lab report. It's a formal, polished document designed to prove the value and the rigor of this AI to any potential partners, whether they're in academia or industry.
And this is so important. Why? Well, for one, it means the research is ready to go. Other experts can look at it and understand it immediately. 2, it provides that clear, definitive cognitive score that you can use as a benchmark to track the AI's progress. And 3, it creates a historical record, like a snapshot of the AI's social smarts at one specific moment in its development.
So, let's leave it with this question. We've just seen an AI that can go beyond our words to understand the very structure of how we connect. If it can master the vibe of a party, what other, maybe even deeper, human connections will it learn to map next? Thanks for tuning in.